I would like to start with just a few words about me. So I'm a DevOps and platform engineer working with Kubernetes. I first came into contact with Kubernetes around 2018. I'm not exactly sure when. And I used to be a front-end developer like 10 years ago, and I really love front-end development still, but not doing it professionally. Kek.im is one of my websites where you can get more links and stuff. And my employee is AOE. We've been in the market for 25 years. And yeah, we are an agile company working on complex software solutions for our customers. We are also doing a lot of consulting at the moment and training in DevOps and Kubernetes. And we are roughly 300 people in 10 locations across Europe. All right, so I want to start with a question. So who can say how many CVEs are currently on the platforms you manage? All right, that's good. So a few hands. The thing is, the trend with published CVEs is going up. So here's the data from the last 10 years. And you can see in 2013, there was a very tiny bar. It's roughly 5,000 reported CVEs. And last year, it has been 28,000. And this year, in Q1 alone, it has been nearly 9,000. So the trend is going up, and there are more CVEs discovered in products. I have a long quote here. I'm going to read it from the BSI, die Bundesamt für Sicherheit in der Informationstechnik. And the quote is, "Vulnerabilities in software products often serve as the intrusion gateway to compromise systems and entire networks, as they are often exploitable via the internet and thus allow attackers maximal anonymity and flexibility from afar." Okay, so yeah. That's a completely new vector that you need to think about in an enterprise context. If something is vulnerable and exposed to the internet, it will be high risk. We can reduce the risk by knowing about vulnerabilities, and it's generally a combination of security practices in technology, but also in culture. Here you can see me again from one of our company internal photo shootings. And here's what we will talk about. So we first talk about how can we identify CVEs in our containers, in our clusters. How do we prioritize them? Then how can we fix them? How do we verify images in our clusters, which is also part of this whole process? Then another important thing, documentation. And finally, our setup. Yeah, so let's get started with the identify step. Oh, I think I was too loud, sorry. Yeah, so what do we need to identify CVEs in our clusters? Basically, our setup has 3 steps. So we have a scanning step where we scan for CVEs, and then we put the results in our registry, which is Harbor. Then we do alerting on these CVEs with Prometheus and Alert Manager, and we do some documenting in our Confluence. There's many scanners available, and we use Trivy. It's the big one in the center. They are also here at the conference. So yeah, if you're interested in Trivy, you can talk to AquaSec. And we, as I said, use it in combination with Harbor. So we have Harbor as our container registry, self-hosted in our infrastructure. And right now we have roughly 11,000 images in it, and we scan them every night. We have 8 Trivy instances for that. They are brought up in the evening, then they scan everything, then they are brought down again. And the results are put into Harbor, from where we later collect them for our metrics. A metric might look like this. So here we have an alert called Harbor in use repository has vulnerabilities. And it's triggering for a few repositories, and the respective teams that are responsible for these repositories or that are maintaining the images will then get notifications. And for that, we use Prometheus and Alert Manager. And the UI you see here is Karma, which is just a dashboard for Alert Manager. Here's the same alert in code. So we have our own metric for that called Harbor vulnerabilities. It has some labels, and it is then turned into a notification or into alert, which is sent to Microsoft Teams, which we are using. And there you see already some buttons for runbooks and to silence it, to create a Jira ticket, and yeah, the history of the alert in Thanos can also be seen. All right, so other practices in general, not directly related to CVE, is subscribing and following people in the security industry, it's always a good way of being notified about CVEs and learning more about security practices. There are some feeds I have listed that I have subscribed, a mixture of like newsletters and media outlets. And I wanted to give a bonus. The Miniflux app is a super simple RSS reader that everybody can self-host. I have one on a Raspberry Pi, for example, to subscribe to feeds. Yeah, and then the more cultural aspect is talking about security. So inside your teams or your companies, you can't just hide security issues, you need to talk about them. You also need to talk about CVEs and document them, which is another topic later. So this is more of a cultural practice. And here's a QR code you can scan. There's also talk notes later, which goes to the aoe.com/techradar page, where we list our tech stacks that we use with some examples and with some more information about our decisions, like different methods and stuff. You need to breathe. All right, so recap. Scan all your images. It's really important. It's relatively simple with the tooling like Trivy. Use the scanner results for metrics and alerts so that you are actually notified if something happens. Alerts again, and stay up to date with security practices in general. And talk about it. It's not good if you try and hide security issues. All right, going on to prioritizing. The question with CVEs is, let's say we have a bunch of CVEs on our platform and there is like 50. How can we say which ones need to be fixed? Do we do them in chronological order as we discovered them, or do we need to prioritize them? And we need to prioritize them. For this, there's different questions that need to be asked, like how critical is the vulnerability? Are we actually affected by it? Can it be exploited in our setup? Is it our software or is it a third-party tool that is raising the CVE? Can we update or can we wait for an upstream fix? All of these are valid ways of handling CVEs. And one thing that helps scoring is the Common Vulnerability Scoring System. It's a standard in the industry, and here again, Aqua has a great vulnerability database. The vulnerabilities are scored from 0 to 10 basically, and the higher the number, the more critical it is. In this case, 9.8 is very high already, and is probably something that should be looked at if this pops up in a container. But also every setup is different. Here, for example, is a vulnerability from this year, rated at 8.1, so also quite high. But we could completely ignore it because we don't have any publicly exposed SSH servers. And we just don't have SSH in our setup. So we could just set it on the ignore list and be done with it. It was an easy fix. All right, gonna drink something. Okay. So how do we identify or define the CVE risk? First of all, it depends, like everything in IT. But basically, these three topics can be used to try and rank a CVE. It's the exploitability, again, very dependent on the setup and the context, which is the second part, and the CVSS, so the scoring. The higher the score, the more likely we should at least have a look at it. Another important thing, especially in our setup, is priorities. So every app in our system, or every service that is running in Kubernetes, every pod, has a certain priority. And by looking at a priority, we can also check if this is a business critical service, or if it's just something that might be not so important. So prioritizing all the apps is also important to determine what needs to be fixed and in what order. All right. And then, of course, define a process. No worries, I will zoom in. This is our process, how we handle CVEs. So basically, we start at the top. A new CVE is discovered. And we first check, are we the maintainer of the thing that is raising the CVE? If we are, then we fix it and roll out a new version. If we are not, we check the criticality. If it is critical, we will document it in the CVE list in our wiki. We're now Then we talk with the team about it, in my case, and we form a strategy to work out how to resolve the CVE. If it's not critical, then we also document it. We might add it to the CVE allow list if it's something that cannot be exploited in our system or isn't relevant. Then we will start with this loop. So we have it in the allow list in Harbor, which is a list of CVEs that are allowed to be on the platform. We set it to expire in 4 weeks, and after 4 weeks we check again. So we'll see, has the score changed, which happens sometimes, or is there a fix now? And if not, then we might put it back onto the alert, back onto the allow list, not the alert list. All right. Yeah, so implement a process for priorities. Define the risk of your apps and components, and also know your platform, and define thresholds. For example, what severity do we need to look at? In our case, for example, the ones we must absolutely look at are defined as high and critical. Medium can be ignored if there's no time to look at it. Sorry. All right, now a bit about fixing CVEs. So we have a CVE discovered, and we want to handle it. And you can already see it in this very beautiful graphic. There's different things. For example, we can update. If there's an update available, then we will just update, and maybe the CVE is gone. We can fork the project and fix it in the code. That might be necessary depending on the component. We can maybe downgrade to an unaffected version. Not so often, I think this happens. We can ignore the CVE, so add it to the allow list and document why it was ignored or allowed for the moment. And we can also take the component offline. So if it's a publicly exposed component and the CVE is severe, then we might need to take it offline and fix it later. One tool we use in our infrastructure for the update process is Renovate. It's a bot that checks the GitLab, in our case, repositories, and automatically creates merge requests for all updates. Here you can see one of those merge requests in the bottom. Renovate has created this merge request automatically, that there's a major update of a Terraform module, and also a pipeline is running. In this case, the pipeline failed at one step, so somebody needs to check why and dig a bit deeper. But normally this can reduce the amount of work in updating things, because we get all of these merge requests created automatically. And you see the screenshot in the back. We also have a Grafana dashboard that shows us all of our updates that are pending and that can be done. They have a scoring. We will talk a bit about that later. And so we have a nice overview of all the stuff that needs to be updated. All right, then fixing something by forking it might look like this in the case of Docker or container images. Let's say we have some image point with the tag 3.1. There's an issue, so we create a new container image from it and pin a dependency. In this case, for example, React. This might actually be enough to fix it. The downside is then we need to maintain our fork of the code. So what if there is no fix actually then? We can add it to the ignore list or the allow list, and that's also what our teams are doing. So when I talk about teams, I mean developer teams. I'm a platform team. We have a lot of developers on our platform, and they can also decide if something is okay to be ignored. They add it to the allow list, and we have a metric for that. So here we can see one team has currently 34 CVEs on the allow list, and they take responsibility for that and say it's okay. It's not fixable at the moment. Okay, the recap. Generally ensure your components are up to date. It's not just vulnerability related, but in general good practice. Sometimes we must fork, but we shouldn't if we can avoid it. Not every CVE can be fixed, and this is also like a cultural thing again. Some people expect like 100% security in all our systems. That's hard. So sometimes you just have to decide if it's worth it to fix something now, or if there's a different solution, like taking the component offline. All right, then about verifying stuff. Basically, sign your container images during build and then verify them during deployment. This can reduce man-in-the-middle attacks and also supply chain attacks, because we have the image signed at one step, and before it is deployed on our cluster, this signature is verified. This is also a bit of a topic on its own, so I will be brief. This is how this can look in our case. In the code example, and the shell example on the right, you can see we are using cosign to sign a container image. In the top part, it's the first step, and then later verify it. And then in Harbor, our container registry, there will be this little check mark on the image which says this has been signed. And then on the other hand, inside the cluster, we have a tool called Connoisseur. And this is an admission controller that actually validates the signature we created during build. It can support cosign, which is the one we just saw, Docker Content Trust, and Notary, but I think Notary just version 1, not version 2. And here's basically how this works in a graphic. So we have the CI pipelines part and the cluster part. The CI pipeline signs the images, pushes it to the registry, and then we start the deployment on the cluster, for example, with an Helm install. And on the cluster side, the admission controller will then come in, check the signature, and if it's valid, allow the deployment to continue, and if not, we'll break it on the cluster side. So we have it's secured on both ends. And the recap here is not so much. Sign your container images and validate them. All right, I will take another sip of water because I think I'm talking a bit fast. Okay, then we continue with documentation. Basically, it's important to have a format that works for you. This can be anything. Here's the 2 examples what we do. Link all relevant information in the documentation you write, and if the CV cannot be fixed, then also document why. So here I have taken 2 screenshots of our Confluence, and basically we always have the status and the affected components in the little table at the top. Then we have some relevant links or information, and in the bottom we have some form of action logs. So we actually put the date when something was done with the CV, because sometimes it might take a bit. Not sure if you can read it, but in the bottom screenshot, the first action log is 2nd of January, and the next is 24th of January. So sometimes they lay around for a bit. Another great tool is the Grafana dashboard again. So this is our Renovate dashboard, where you saw the bottom in the last slide. It's the top of it. We have metrics from our Renovate bot, so we always know what updates are on the platform or what updates need to be done. It is across all of our repositories, and it also shows the CVE metrics, so the metrics that we gather about criticality and what is on the platform is also shown here. And this is a bit special because it's not just Kubernetes, so we run this against the Renovate bot, which runs against GitLab. So this is an overview of all of our infrastructure code as well. So all Terraform modules, all Helm charts, all dependencies from team like Java or Node dependencies. They are all in this dashboard. And here's again the bottom view. So we have a score of 1 to 5. 1 is not so critical, 5 is very critical. It's also in the table very dark red. So it's really catches the eye. We have the links to the GitLab merge requests directly in the dashboard. So every once a week, one of our team will sit down, open this dashboard, click on the most important updates, check if they can be merged, and then merge them. And yeah, it's an exporter, custom metrics exporter that we have written. All right, so the cultural aspect of documenting. I think like the blameless post-mortem, I think, which was introduced by Google and the whole SRE thing. We can also do blameless vulnerability documentation, because we don't want to look at the data and blame the teams, like Team X is using software or building software that has 20 CVEs and team Y is so much better because there's only 5. That's not the point. The point is to be aware of what is on the platform and to try and fix it together. Yeah, do not hide the problems. It's the same basically. And make sure everybody knows about the vulnerabilities and the process also. So how should it be handled? And also another thing, take time for actually managing the CVEs. If there's a critical CVE or one that needs attention, create an actual story or a task for it and work on it and not just do it in between meetings or whatever. All right. Yep, define a documentation process, gather the metrics and use them. Metrics are super helpful. I mean, you've seen the dashboards that we had. It's a lot easier to look at them instead of a bunch of GitHub repositories or GitLab repositories. And teach the ops and the dev people the process. So always be in the loop with them as well. Okay. Then we continue with our setup. So this is now a quick overview of what we actually do on our platforms. Basically, this is our tech stack. So we have, as I said, Harbor as our registry, where we put all our container images and also all of our Helm charts. Then we have Trivy as our scanner for CVEs. We have Connoisseur and Cosign to sign and verify the images. We have GitLab as our code store and CI/CD pipeline runner. We have Renovate for the updates, some custom tooling, and Prometheus and Grafana. And I think I forgot Kyverno at the top. It's a policy engine. There's a slide later where I talk a bit about it. Yeah, so now some code. You don't need to read the code. It's just there because the slide would be empty otherwise. So this is the so-called Harbor vulnerability exporter. That's actually the tool that we have that reads from Harbor, our registry, all the CVEs that are assigned to image and converts them with some Python code into a Prometheus readable metric and then push it to Prometheus push gateway. So this is how we get all of these CVEs out of the Harbor registry. And I talked to somebody from Aquasec, and they are here, as I said, and they said that they also have a Trivy operator now, and this has metrics as well, so we might be able to get rid of this custom solution. But another tool that we have is the so-called Harbor label machine. This is running as an admission webhook in Kubernetes. And basically, whenever an image from us is deployed, it will check the image, find it in Harbor, and assign a tag to it that this particular image is now in use on a specific cluster. And this tool, plus the vulnerability exporter, is how we can gather the metrics to know which image has which CVEs and is in use on a specific cluster. Because otherwise there is no connection between the two. And as you can see with the names, there's a lot of people in the team who prefer different types of naming. But yeah, basically, this way we can, for example, get the alert there is a vulnerability with a score of critical on the cluster production. Please have a look at it. And then there's another component. They have all grown over time. This one is just a cleanup job. So this looks at what is on the cluster right now and what is labeled as in use in Harbor and will clean them up, the labels, because the admission webhook is only applying new labels. Okay, so then again, I will zoom in. This is our workflow that we have. Basically, one is for the build and one is for the runtime. We will start here. So we have a developer and they are pushing code to GitLab. Then we build the image and push it to Harbor. Then we run some image scanning on it with Trivy. And then we have the first decision, is there a vulnerability? If there is one, we will go quickly to the right. We can ignore the CVE for urgent hotfixes. Otherwise, we will run break the pipeline. If there is a vulnerability, if there's no vulnerability found, we continue. We deploy to the cluster we use Connoisseur to check the signature, and if everything is fine, then the pipeline succeeds. If at this point the signature cannot be verified, or there was a critical CVE and it is not a hotfix, we go into this little loop here. Oh, sorry. And we basically start by prioritizing the vulnerability. So again, we look at the criticality, we document it, we fix, mitigate, or accept it, all valid, and we add it maybe to the allow list in Harbor. So that's the step that can happen when a developer triggers an update. On the other hand, is the thing that happens all the time in our runtime. So again, we have Harbor, and every night we scan all of our existing images. So at the moment it's roughly 11,000, and we will scan them every night. You may wonder why scan them every night, because there could be a new vulnerability like all the time. So we want to know if the current images or any of the past images that we keep have had a vulnerability. Then we gather the metrics. We get the data from the admission controller that we had that puts the labels on it, and then we export everything to Prometheus. Then we have the check if something is critical or high, and if it is, then we send an alert. All right. So then we have the concept of runbooks. It's a little bonus now. Also not directly related to CVEs, but basically they answer the questions, what is wrong at the moment, how can it be fixed, and where to look for more information. So if I'm new to the team and I get an alert, I can click on the runbook and I see what's the context about it, what needs to be looked at. The runbooks are also added as labels to all of our alerts, so they can be linked directly when we receive an alert. Okay. That is written. All right, and now Kyverno as the last example. So here again, a nice dashboard. That's our Kyverno policy reporter. So Kyverno is a policy, I'm not sure if engine is the right word, but a tool where you can write policies that the stuff on your cluster needs to adhere to. And they are to harden security. And violations will send alerts. And here are some of the things we enforce. For example, no developer can deploy a latest tag because that's not reproducible. Developers cannot launch privileged container, and they must set the read-only root file system. So whenever somebody tries to deploy something onto our platform that is not in line with these policies, they will be either alerted or the deployment will be rejected. But that's just a little bonus. And I think I'm pretty okay in time, and that's it. So thank you very much. My colleague, who's also named Kevin, will be having a talk at stage K1 next talk. You can follow me on the Fediverse at kevingimbel@fosstodon.org, or you can go to my website, either scan the QR code or go to kek.im. And lastly, if you are DevOps and looking for jobs, then we are always hiring. So jobs.aoe.com. And thank you very much.
Thank you, Kevin, for sharing all this. We have so many questions, so let's get into them. So, do you have a dedicated team sorting out CVEs?
No. We don't have a dedicated team that is managing the CVEs, but we have a special concept, I would say. We do sprints like most people, but 2 or 3 people each sprint are dedicated to do all of the ongoing processes. So they will handle support requests, and they will also manage the CVEs. And this changes every sprint, basically.
Okay, so you kind of answered this one. So on average, on a feature team, how many hours does it take per week? Do you have a rough idea about this?
No, actually I don't have no. I mean, the teams, they get an alert, and then it can be anything from 15 minutes to a day or more, so it depends on the alert. But the important thing, again, is not that they fix everything, but that they document everything and that everybody is aware of what is happening.
Mm-hmm. All right. How do you handle unknown severity CVEs?
That's a good question. I'm currently not sure if we have a special alert for that if something is unknown. Otherwise, if there is a CVE that has not yet been rated, we might not be able to get it on time, like when it is published, but only later. But that's also why there was the slide about following security people and everything, because if something big is coming up and it might not be rated, or if something is fishy, they will post about it.
Do you prune all the images to speed up scanning?
Yes, we do. So the 11,000 is already with the pruned images. I'm not sure about the exact number. I think it's 3 or 6 months that we keep, or either that or the last X images of each repositories, but I would have to look it up. But we prune old images.
Okay, next one. This is a conceptual thing, like patching containers?
No. So I don't know of a tool, and we are not doing it. We don't patch containers if we do the fork thing. If something in a container is having a CVE.
Yeah, so basically rebuild it every time when you update stuff. Makes sense. Oh, sorry, I pushed too many buttons. Yeah, so I just wanted to highlight this because I enjoyed the pragmatism in your talk, because there are some, 100% security and fixing all CVEs would be like a tremendous job. But for example, this one you mentioned that you don't fix SSH servers when you don't expose SSH itself.
No, we don't have SSH on the server. So we are using Amazon managed Kubernetes, and during the launch of the instance, we actually delete SSH completely from the servers. So there is no SSH on the server.
Yeah, so there is no package on it. Makes sense. Okay.
And also not in the container images. So that's why we could ignore this. Obviously, if it was just inside a private network, then we would need to fix it. Mm-hmm. That's completely correct.
One more. So how do you handle CVs in base images, and what's the process around that?
Yes. So if something cannot be fixed, you can either add it to the allow list for a short time, or there is in the GitLab CI is a special switch that we built in to push the deployment through anyway. This was in the very big flow chart, the part about pushing hotfixes despite CVEs being present. So we will break pipelines automatically if there's CVEs, or we will stop them, but there's an option to run them with the checks disabled in case it is an unfixed CVE or unfixable.
All right. Thank you very much, Kevin. I think it was very useful for many of us for our day job. So,
Thank you very much.